Hi, my name is Julie Williamson, and today I'm going to be talking about digital proxemics, designing social and collaborative interaction in virtual environments. This is work I completed with my colleagues Joseph O'Hagan, John Williamson, John Alexis Guerra-Gomez, Pablo Cesar, and David A. Shamma. Let's get started. I want to start by talking about what is digital proxemics. Digital proxemics describe how we use space in virtual environments and how the presence of others influences our behaviors, interactions, and movements. Proxemics is pretty well understood in physical environments, but we don't really understand yet how these metaphors translate to the virtual, how the change in social signals, how we're represented, how we interact, how all of these things impact our experiences in virtual environments. So we want to look at digital proxemics quite broadly and map out a little bit what this research field is going to look like. We thought about digital proxemics as a roadmap across 4 themes. Firstly, you have to think about the activity which is going on in that virtual environment. Is the activity unfocused, or is it focused on a specific point? Is this a very structured activity, or is this informal? What are the social rules around access, participation, and behavior in general? In the case of this study, we actually used a focus task, specifically a consensus-seeking task, to get people to discuss, negotiate, and have those interpersonal interactions in a virtual environment. Secondly, we need to think about social signals. Social signals can be everything from our facial expression, gestures, body position and pose, our orientation to other people. All of the signals that we give or give off in a social setting can be used as information to analyze our interactions and behaviors. In this case, in this research, we looked at 2 different devices, a desktop PC and an HMD, that have very different affordances for social signals available and how this might change the way people interact. And it's also important to consider speech and audio. There's a whole wealth of information that comes out of our speech when we talk about collaborative tasks. For example, when speech is overlapping, when there are gaps, and in general, how successful conversation can be. And additionally, how we perceive audio, speech, and the sounds of other people in a virtual environment. In this research, we looked at 2 audio attenuation models to see if this changes the way people interacted. And finally, environment is a key part about proxemics. It sets the scene for where we can interact and provide affordances for movement and position and using the space in different ways. Interestingly, we're not constrained by the physical in a virtual environment, so the sky is really the limit in what types of environments we can create. Although we didn't look specifically at environment in this paper, this is a very interesting future direction. Our evaluation used an instrumented virtual environment in Mozilla Hubs to complete all of these studies. You can find the full details about this in the paper. I'll go through a quick tour of the experimental design. We looked at HMD users versus desktop PC displays. Again, these had very different social signals that are afforded when you access a virtual environment using one of these common devices. And secondly, we looked at inverse versus exponential audio. These 2 audio models have very different user experiences. In the first case, in our inverse audio model, which most closely resembles a physical environment, audio trails off slowly, and in Mozilla Hubs, you can always hear that there are other people nearby. In contrast to this, our bubble model, exponential audio model, quickly falls off to 0, and so you have to stand close to people to hear what they're saying. This creates little private bubbles in the virtual environment that are bounded by proxemic zones. Doing this analysis, we found some really interesting behaviors around attention and how we perform our attention for other people. On the left, we have the PC users, and this visualization shows each individual in a small group, and the center point is their perspective. Their field of view is marked by that arc, and the people around them are marked as a gray dot, and the dot is turned red when that person is speaking. All the participants in a small group are overlaid here on the same plot. We see with the PC, there's no tendency to turn towards the active speaker or even keep people within your field of view most of the time. This is very different than the PC user, or from the HMD users, where they turn to face the active speaker. They generally keep other people in the group within their field of view, and they're using that body language to perform their attention. They turn to face the active speaker. This change in social signal that's made so easy within HMD really changes what that behavior looks like in a virtual environment. We also saw some interesting differences in how people use personal space. So in the small group discussions on the desktop PC, we see collisions in the intimate zone, a lot of the interactions happening in the personal zone, and very little happening in the social zone. This does not match what we would expect to see in a physical face-to-face environment. In contrast, the small group discussions in VR, we see almost no collisions in the intimate zone, a limited amount of interaction happening in the personal zone, but the majority of interaction happening in the social zone. The ability to kind of claim personal space by gesturing in front of your body, moving your head, all changed the way that people formed small groups. These interesting differences are really exposed by this quantitative analysis. I want to conclude with a few final messages. Designing effective experiences for virtual environments requires an intricate knowledge of how people make use of and behave in virtual spaces. In this case, we found already so many differences between how people behaved using a PC versus an HMD, and there are definitely ways that we could improve the parity of different devices accessing a virtual environment, and that we could help to preserve some of those interpersonal human skills that we lose in a virtual environment when we lose some of the social signals we're used to depending on. Although this research only scratches the surface of the broader challenges, we hope this inspires future research into digital proxemics and improves how we collaborate and socialize in future environments. And finally, all of the code, data, and Jupyter notebooks used in this research are available open source in the ACM Digital Library. So definitely check out our paper if you have more questions, and all of those resources are available as well to show how this research was done. Thank you.